Hey guys, Mr. Gran, third installment of sine and cosine graphs. Now we're going to take on vertical stretches and vertical reflections of sine and cosine graphs. So again, our rules for vertical stretches and compressions, I should say. If it is a times sine of x, where we're multiplying on the outside of the parentheses, right? There's no parentheses inside here. So this is a vertical visitor. It's a vertical shift, or a vertical stretch, excuse me. If it is a is greater than 1, remember if you multiply something by a number larger than 1, the product is going to get bigger, right? So that is a stretch if a is greater than 1. If a is between 0 and 1, so numbers like 1/2, 1/3, 0.8, stuff like that, then it's going to get smaller, right? So that is going to be a compression. All right, so now one thing with this is going to change our amplitude, right? The amplitude is the height from the midline to the top. Well, if I stretch it out vertically, that amplitude is going to grow. So A, and I'll even put a plus there to say make sure that it's positive. Amplitude is always positive. A is equal to your amplitude. Amplitude. All right, then a vertical reflection. All that a vertical reflection is if there is a negative in front. So if you multiply cosine of x by a -1 in front, that's going to flip it vertically. That does not change the amplitude, and again, reiterate, the amplitude is never negative. Okay, I think that's all I had for that. All right, so we'll do 3 examples. Probably a stretch, a compression, and then one that's got a reflection in it. So y equals 2 sine of x. This is going to be a vertical stretch of 2. This is not going to affect our midline. Only a vertical shift affects our midline. It is not going to affect our period. And the amplitude is going to be +2. All right, so knowing that, I do need to think about my vertical scale a little bit, because I need to be able to count up to 2 and down to -2. So we're not shifting side to side at all, so we can use the same old horizontal scale. But I do want to just make sure that I can fit like that. All right, now I'm going to start this by using my important points. I'm going to start with my important points, right? For sine, it goes 0, 1, 0, -1, and 0. Now let's think about what happens if I multiply the height of each of these points by 2. If I multiply 0 by 2, it's still 0. So this one doesn't change. If I multiply +1 by 2, it stretches up to 2. If I multiply this 0 by 2, again, it's still 0. If I multiply -1 by 2, it stretches down to -2. And then this 0, again, remains unchanged, because any of the zeros, you multiply it by whatever, it's still going to be 0. All right, so now I just have to square my shoulders and trace through a nice smooth line, and voila, a beautiful sine graph. All right, let's take a look at a compression now. These two are going to remain unchanged, so I'm just going to leave that there and save a little expo marker, because I'm going to waste a bunch of expo marker by redoing my axes every time. Okay, we're multiplying by 0.5, so this is now a number that is less than 1. So this is a vertical compression of 1/2 or 0.5. Now, I think in the homework quizzes it's mostly in fraction form, not in decimal form. So just be wary that, converting between decimals and fractions, hopefully you can do that. It's not, I don't think that's too big of a stretch. Okay, amplitude then is either 0.5 or 1/2. Horizontal scale can remain unchanged. Vertical scale, I need to think about a little bit here. 0.5 isn't too tough of a vertical scale to wrap our brains around. If I say that is 1, I guess just count by an even number so we can split it in half. So if I say 4 squares is 1, then 2 squares is 1/2. Our important points, 1 for cosine. Remember, it's sort of the C-shaped graph. A C that's tipped over, fallen on its back. Now, what happens when I multiply the heights of each of these by 1/2? Well, 1 times 1/2 is 1/2. 0 times 1/2 is still 0. -1 times 1/2 is -1/2. 0 times 1/2 still 0. 1 times 1/2 is 1/2. Like that. And then we can trace through with a nice smooth line. All right, last one. With a reflection. Now there's a really common error I'm going to go over here. And if I see that you make this mistake, I'm going to know that you weren't really paying attention to this. All right, so I know the midline doesn't change. The period does not change with a vertical stretch or a vertical reflection. Transformations. This is not a vertical stretch of -3. It is a vertical stretch of 3 and a vertical reflection. So 2 transformations there, right? These are 2 separate things that are happening. It's stretching and it's also flipping. 2 movements. All right, our amplitude then is not -3. Amplitude, much like your math teacher, is always positive. So it is a +3. All right, horizontal scale, we're not moving side to side at all, so that can remain the same. Vertical scale, though, we're going to need to think a little bit about. 90, 180, 270, 360. Let's see. I need to make sure that I can count up to 3 and down to -3. So let's do like this. It's sine, so we're starting at the origin. We're moving up to 90. We're getting that S-shaped graph instead of the C-shaped graph. And now what happens when I multiply each of these by a -3? 0 stays the same. 0 times -3 is still 0. 1 times -3 is down here. 0 times -3 stays the same. -1 times -3 is +3. And then 0 times 3, -3 is still 0. And now we can trace through with a nice smooth line. And now it's just like your other sine graphs, except it's stretched and it's flipped vertically. All right, so that's it for sine and cosine graphs. Let your teacher know if you have any questions. Have a great day.